Let's talk about idle jetting and off-idle jetting. This is my jetting chart right here, which I made with the help of my jetting calculator. Up to 1/4 slide open, not throttle open, slide open. You can see that the main things that affect the jetting are the needle jet clearance, which is the clearance between the needle, the straight portion of the needle, and the needle jet, the slide cutaway, the idle jet, and the air screw. Sometimes people have too much clearance or too little clearance, and they make up for it at idle by changing the size of the idle jet. So right there at idle, the two will still, you can make it balance. Okay, but once you get off idle, the idle jet becomes a lot less important, and you still have a big influence from the needle jet clearance. So off idle, you're going to be too rich or too lean depending upon the needle jet clearance, and that's how you normally know, especially if you wind up making the idle jet really far off from the stock idle jet, if you have a stock bike, that is. Right here I have a graphic showing the different carb parts. This right here is the needle shroud, which is this right here, the half circle extension from the needle jet. Not all carbs have them. A lot of the Del Orto carbs that are made for street bikes do not have them. The higher that shroud, the more suction you have on the needle jet. Right here you've got the needle jet, this straight hole right here. And here's another illustration of it right here. And then you have the main jet, and always what's coming up through here is a combination of the needle jet, the needle, and the main jet. It's even at wide open throttle, it's not just the main jet. These two also come into play. So we've got the idle air screw, which regulates the amount of airflow that goes to the idle jet, and that mixes with fuel, comes up through this hole into the airstream. So here's the slide cutaway, the slide. The one thing that's missing right here as important parts is the adjustment on the float that determines the level of the gasoline in the float ball. The farther that fuel has to be sucked up to get from that top level of fuel to the venturi of the carburetor, the more vacuum is needed. So it affects the jetting. If you have specs for that carburetor, then follow the guidelines for setting that fuel level in the float. If you do not, what I do is I tilt the carb, and when it reaches 30 to 45 degrees, tilted back from vertical, the fuel should overflow. If I was going to be doing a lot of off-road riding where there's steep hills, probably I'd set it to overflow around 45 degrees. For street use, 30 degrees would be fine. So you adjust the float level for that degree of overflow. Okay, so that's the float level. That's the starting point of all jetting, and getting that float level right. Because you can take a carb apart and just accidentally bump a little part on that float, and it'll change the level, and you'll be scratching your head why things are different after the carb is nice and clean. At 1/4 slide open, most carbs do well with the beginning of the taper, which I've got designated by this very fine line right here, at the top of the narrow portion of the needle jet. It curves open, so you can't look at this part right here. You have to look down in here where it's narrow. If you're starting off with a carb setup and you don't know what to do, this is one of the steps I always take when I'm setting up a new carb, is set that slide at 1/4 open, and then make sure the needle height is so that that needle tapers at the top of the needle jet. So in every portion of the jetting, there's an area that's good enough. Okay, there's the perfect and the good enough. And so the different jets, the different needles, you can get some variability there. Maybe on main jet size, that might be 3 different main jets that are acceptable. I'll go into more whether or not you would choose a main jet that's over here or a main jet that's over here, richer or leaner. What I do for idle jetting is there's different, how easy is the bike to start, how smooth does it idle, and how is it with off-idle jetting. Sometimes you have to compromise these two to get this right if you don't want to change the needle jet out or the needle. If you want perfect jetting, yeah, you've got to mess with the needle and the needle jet. But for most people, they just want their bike to be, as good enough as they can get it going without digging into it and replacing parts. So, correct idle jetting, when the weather is cold, you have to use the choke. If you can start it without the choke, the idle jetting is too rich. In the summer, yeah, you can start it without the choke. Maybe in spring and fall, maybe it'll take a few kicks more, or you might wind up just going up a size in the idle jet. Smooth idling, what I do is I turn the air screw towards idling the fastest, bring that idle down a little bit with the slide stop screw adjustment, and then start turning it to the right, and then where that idle speed starts to drop off, that's where I leave it. Just a tad on the rich side, okay? But the idle jet size and the idle air screw setting, maybe the off idle jetting is so far off, you've got to compromise those to get that right. So it's just, what's most important to you? What's your criteria? Then there's the slide cutaway. That affects everything also up to 1/4 slide open. You can see here after 1/4 slide open, it just dwindles away in effectiveness up to 3/4 slide open. So the lower the slide is, the more effective the slide cutaway is, the more important the slide cutaway is. About the slide cutaway, I've taken it both ways, made it both leaner and made it both richer. Let me show you how. Little southern ingenuity. You can drill holes into the slide, and you can always fill them in later with a JB weld if you don't like it. I've also used my rotary tool with cutting disc to put these grooves into the cutaway, this edge right here, the cutaway, and then put in JB weld put electrical tape over it and let it rest so that the JB weld goes towards the electrical tape, so it'll be nice and even, the same level as the rest of the slide. And then going back later with the rotary tool and making this more flat, more even, more curved the way I want it to be for the ultimate extension, however many millimeters I wanted to try right here. And again, if you don't like it, you can just use your knife or the rotary tool and take that off. And you can leave the JB weld in the grooves. It's not going anywhere. These can be permanent changes or they can be temporary. You want to buy the right slide, you do these kind of modifications and tests to know which slide would be best without having to go through the expense of buying a few of them. Yes, it's Southern Engineering, and guess what? I'm from Texas, okay? This is a picture of my slide after I put the grooves in the edge and built it up with JB weld. I think I did it in 2 different passes, which is why you can see the different colors right here. Worked well. Never came off. What a lot of people don't realize as a result of the very poorly made jetting charts that we had in the past is that a lot of fuel comes up through the needle jet during idle. On some carbs, as much as 50% of the fuel comes through the needle jet. The very first carbs, back in the olden days, didn't even have an idle circuit. All their idle fuel came up through the needle jet. The carburetors that are sold on motorized bicycles are that way also. They do not have an idle circuit. So even though the old charts show that there's no fuel during the idle from the needle jet, they're just wrong. If you don't believe me, put silicone sealant here in the main jet and start it up and see if there's a change in the idle. If it's weaker, if it's lower, if it's faster, whatever. Some bikes have down to about maybe 15%, so it depends upon what the percentage is, how much you'll notice it if you do that test with the silicone sealant there. So that's some of what complicates the situation, that we're not dealing just with the idle, we're also dealing with the needle jet, which is a combination of the needle jet, the needle taper, the needle width, and the needle height. Yes, it does get complicated. Which is why I made my jetting calculator. When I started off in the wide world of impossible jetting situations, I had an AX100 and the factory put the wrong needle in it. So I had, as a result of making a jetting calculator, I was able to realize that the needle taper kicked in too early. And so I had to dig a well into the slide where the needle clip rested, so the needle could go down farther, so that it could open, so that it could be at this setting. With 1/4 slide open, it's at the beginning of the top of the needle jet. So yeah, this jetting calculator is awesome. You put in all the stuff, all the details that it asks for, and then you just look at the jetting chart. Like right here, it's showing that it's lean, how it dips down below the 1.0 line at 3/8 slide open. It's very uncommon that for the first half of the slide opening, this is really good jetting, which is what you want for a street or a trail bike. On racing bikes, all that the rider normally cares about is half throttle on up to wide open throttle, because that's almost the only positions they use on the bike. I'm riding on the street, so I'm more aware of the full range of jetting. Okay, that's it for now. I'm going to continue this teaching series on the next video. Thanks for watching.